Okay, uh, just a couple things to mention this week. Let me see if I can get screen sharing going here. Well, before I start sharing screen, I a week or so ago I had mentioned a new PCB design software. I think it was called Easy EDA, and then I shipped off I don't know if they're Gerber files or I forgot which version they were, but uh, you get five of them in a package, and I think with shipping and everything, it was $15 maybe, including shipping. Anyway, so I was doing that so on my tractor I could have a holder for the ESP32, and as you can see, there's five what are different wire terminals. So they would be screw down wire terminals that I would include on that board. So that showed up, and the holes all fit, at least for the ESP32, which is good. And the wire terminals will show up from Amazon today, so I'll be able to make sure that those holes are going to fit for the Amazon terminal. So that's what the backside looks like. But it's for a simple board. I mean, I'm sure you can get more complex with that software. That's beyond my current skills. But for a simple, just sort of breakout board that you can fasten down and provide some protection for the ESP32, I think that'll work out really, really well. And Jeff, if you wouldn't mind sharing that Slack post, uh, the other thing I was working on is cleaning up my speed data, because getting consistent speed for my tractor is, I guess, my next milestone. And when I was running previously and captured the ROS bag and then analyzed the data in Plot Juggler, if you see that graph there, I don't know if Jeff, you could click on that graph just to make it a little bit bigger. You can see periodically I was getting these spikes in speed. Now, this is calculated speed data based on my rotation sensor, and the rotation sensor is 14 bit. So when it gets to 16,000, whatever, 485 or 384, I forget what that number is, um, then it goes to zero. But about 0.5% of the time, which these are whatever that is, 5 or 6 points um, in that what looks like 135 to 170, so 30-second interval. Um, I was getting those spikes, and what those spikes are caused by is, it's expecting to go from, let's just say, 16,000, and the next reading is going to be 50 because it's gone over that zero. It was getting some weird intermediary value, and then it would take two readings to get the delta back to something that was understandable. So anyway, I've got a couple of different approaches to trying to filter that out, and in the middle of testing that to make sure that it works. I started just testing with batch data, and now I'm trying to test with the real-time data. So that's been a learning experience for me, but I think I'm getting there. In this particular time segment, you can see the purple represents the corrected, and the blue is the original data that I was given. I've not tried to smooth it. Although I did try to put a Kalman filter on there first, and then just a moving average to try to take out those blue spikes. I wasn't happy with that, so I spent a little bit more time looking at the data, and I think with a series of about 6 conditions, um, I can pinpoint those blue spikes and pull those out um, specifically. So it'll take a little bit more processing on the microcontroller, but anyway, that's where I'm heading on that. Let's see, I think there was one other thing I was going to mention, but Oh, I had posted on Slack that Jeff had um, pulled up a video from a homebrew robotics, or one of a maybe a spinoff group from the main homebrew robotics, and there's a guy who was going through in great detail his robot. He had done a zero turn motor, and I'd only gotten through it so far to see how he built his servos. But it's definitely worth a watch. And Jeff is showing there that video. I happened to download it as well, which I didn't know how long that video was going to be up, so I just decided to download it. But yeah, well worth the time to look at that. And Bob, if you're watching, I saw your post about pictures on how I mounted my rotation sensor. I'll, I'll post something here in a bit, but stay right there for a second, Jeff, if you would. Scroll up just a little bit. There you go. See how see that 14077? I mean, that's a raw sensor reading 14834, 15624. And as you can see, each of those deltas is, 700-ish. I call them ticks. And so you would expect the next one to be uh, an addition of 700 to that 1564 minus the 2 to the 14th. But instead, I got 6563, and that's what threw everything off. So the logic will calculate, if you look just below that, it goes 15,624 to 10 to 810. So it calculates what's that right, correct rollover, or an estimated value of what that rollover value should be. So that's what I'm in the middle of testing and reworking on mine. So that's where I'm at. A little bit of progress. Still trying to get clean sensor data.
You actually have, I guess, three different places where you could address that. First of all, you've got a separate sensor on the right wheel and a separate sensor on the left wheel. You could go in at that point and um, check for rollovers, or check to see if one side's doing it more than the other, just for whatever reason. I don't know if maybe you gotta. It could be something funny, like one of your gears on the wheel are, one is a little more sloppy than the other one. I don't know if a mechanical problem would cause that or not. But anyway, you could check at each wheel, before you send the value out. You could check there to see if it's doing what you expect it to. And then I assume you've got a third processor somewhere that accepts those two messages and compares the two. So you got three different places you could actually look at that and see if you can tell, which side it's coming from, or maybe get some idea why it's doing that. So. And didn't
Yeah,
you say
that's
you're also only doing this like at 2 hertz rate or something? So it's a fairly slow. You're not checking it very often. Is that what you said?
originally I was not. No, in the new code, I decided to bump up it to 10 hertz. But you're right. Earlier I was down around 2 hertz. My first thought was I was um, making a turn and the wheel was spinning, which still could be, but that's another thing that I was thinking. But going back and looking at the left wheel data to seeing if it's more or less prone to these errors, yeah, that's a good point, because I have the data, but I've not done the analysis to sort of see how many times is it I'm getting that anomaly data. I was, and on one, I was messing around with two different microcontrollers at one time. So I've got a Teensy on one with, I don't know, 4.7K or 10K resistors for pull-up resistors. And on the Nano Every, which is on the other wheel, I don't have pull-up resistors. So that's another thing that I thought of down at the sort of the electrical level. Is something going on with my pull-up resistors somehow triggering that? If I really wanted to solve the root cause.
I think it's going to
More,
turn out to be a timing issue, just simply as you get to the end. You get the point where it's ready to do a rollover. I think it just simply you got a like a 50-50 chance you get the right number or the wrong number. They're going to be just slightly different, and that's probably where that's coming from. So I don't know if you could completely get rid of it other than verifying that it did roll over and then subtract off whatever. If you do it at the wheel value itself instead of you say taking an estimate of approximately 770, you could probably just say, oh, uh, like you were doing originally, where it would say it would roll over, and you say if it's the number is off by some amount, then subtract the 16,384 or the 881.92 or whatever the number is. Yeah, that might be better to do if you just say, yes, I had a rollover problem on this particular sensor, and fix it at that point before you send it on. And that way you're not going to have to be doing other, guessing at what the number should have been or whatever.
that's another good point. I mean, you didn't state it this way, but um, the error rate that I quoted is on total records. It's not on rollover events. So I know that 19 of the rollover events, I got this goofy piece of data, but I don't know what the denominator is. I didn't count just the rollover events, which is that's another piece of data I think that I want to look at
And
because
if you
you're,
if you look at the left wheel and the right wheel and see what numbers are coming out, you might get a better idea of why it's doing it in the first place, to see if it is at the sensor rollover, or if it's, yeah, I suppose it could just be picking up a bad number for whatever reason, but I don't know. If you get more numbers there to look at, and then just figure out what to do with them once you have them, to give you an idea of what's happening there. I'm guessing it's
yeah, that's
probably
helpful.
not an I squared C problem. You're talking about pull-up resistors. I'm guessing it's probably not that, but I guess it could be.
All good things to check. Yeah, now I'm nervous how many rotations did I actually have because 19 is a pretty high. I mean, that would be 60 feet and maybe 300 feet. So just a round guess, maybe 20% of the time I'm not getting smooth rollover. It's just a guess, but anyway, that's where I'm at.
So I
Well,
just look.
that's just a short, whatever that is, 35 seconds.
Yeah, I was looking at this to see if the spacing between these and these are the same, and these are a little bit closer. But then again, you're actually see you're running at a faster speed too, so it could be that if you just take this number and that number and subtract them and find out how many counts apart is that, you should be able to tell where your wheel was actually where it was actually turning at that point.
Hmm.
And then I hear you just got one out there, so I don't know. It's good. It looks like it's one of those random things where sometimes you'll get a bad number for whatever reason, because it's not consistent all the way across here. So, but anyway, it's just more things to look at. And number one, decide, is it just your right wheel doing it, or is it your left wheel doing it, or are they both doing it? It could be they're both doing it at different times, and that way you'd have to fix it at the higher level, I suppose, if you just get random values. And then you check, like say the values you're looking at right here. I assume this is at you've taken the sensor from both wheels, and you've done your calculations, and then one of them occasionally has a spike on, so you're trying to fix that.
Yeah, you're just looking at right wheel data there, just FYI.
Oh, okay.
And I'm thinking it would be interesting to plot on that. Where were the where are the valid rollover events? Just to give you a visual, but it's
Yeah.
just
Another interesting point looking at this graph, you notice three of the spikes are like at about 6.5, and two of them are about 4. So two of them are at one level, and the other three are a different level. They're not just random spike levels there. So that might give you another clue too as to why you're getting those kind of values out. But anyway, that's just more things by looking at the numbers here to
More ways to poke around the data.
yep.
That's where I'm at.
So how's your weather doing there? Is it does that hold you back or is it
Um, no, I had surprisingly a number of good days to get out and test. So um, it's rained the last few days, but I've been recoding speed sensors. So I think I'm in good shape, and we're coming into August, and although it'll be hot, hopefully relatively dry.
yeah, it's rained the last couple days here, but then again, I don't go out and do anything anyway, so it doesn't really it just doesn't really affect me, I guess. I keep thinking I should just bolt some stuff on my lawn tractor and go out and drive it, but I haven't done that. So
You'll get around to it soon enough.
oh, I'm sure I will someday. So I don't have anything for this time. So do you have anything else?
I'm all set. Thanks.